Hello world! Welcome back to building a roguelike in C. Yesterday we left off, we built out our basic game loop, we enhanced it with some user input, and we got our little @ sign moving around the screen, so let's just quickly show where we're at. Alright, so we've got our little guy moving around, and then we programmed it so we could use the arrow keys to get him moving around on the screen. So today, now we also started to approach the problem of how we're going to represent world state in the roguelike, and I kind of punted on that decision because it's really not one that you should be flippant about. So I wanted to at least sleep on it, and I was basically doing some research on entity component systems and dreaming about components and systems and all of that. So I think I've decided that we will go ahead and just go whole hog with the entity component system, including representing our map and tiles, and just kind of see how it goes. If we go down the road a little bit and we find that it's too cumbersome or that we took a wrong turn, we just back it up and try a different route. But I think we should just go for it. Let me close this terminal. And if you're interested in following along, right up here is the GitHub link to the source code repository. So if you want to follow along or tinker with the code yourself, you can grab that and play along. Alright, so also a notebook here. I was writing some stuff down. Sometimes it helps to just think things out on paper. What's this to? Alright, so new. Start by defining a simple entity in the entity system. We're going to just call it a game object, I think. So and so the game object component itself, or the data structure itself, is going to be very simple. Basically, we're going to hold, and each game object is going to have an ID. That will be unique across the entire world state, and then each game object, I was thinking about it, in some ECS systems, they don't have the components embedded directly in the game object, but I think I'm going to at least embed a reference to them in the game object so that we can then go, instead of having to traverse, let's say we have a big list of components that each one is pointing to a different object, instead of having to traverse that entire list and figure out which component corresponds to the object that I want, I think it'd be far more efficient to have the object itself just say, this is the one I want, point right to it. So to be more flexible, we're going to make it a void pointer, and it will be basically an array of void pointers. And the size of our array, let's define let's call it max component count. Let's give it, for now, let's just call it 100. Again, we're going to have to kind of feel things out. Alright, so that is our game object. And so the next thing that I was kind of thinking about, oh, we're going to need to define what is a component. So let's start enumerating our various components. And one neat trick I like to do with an enum, it's just, so first, let's see, game component. We'll make the last item in that component list component count. So as we add, we're going to add all of our different component types above, up here, and then this will always represent the count of components that we have defined in our game. Alright, so I've also written down a couple components that I can see that we're going to need right off the bat. So, many items in our world are going to need a position. And then we'll have the concept of visibility. We've got this one, well, let's just say physicality. So if something is physically in the world as opposed to being like temperature or something is not a physical aspect, but if a wall has a very physical aspect in that you can't move through it, as do other things like monsters or layer itself. So we'll do that. And then we'll have the concept of health. So that'll represent like hit points and stuff. And we'll start defining these individual components in terms of the data that they need. And then there's one, so not sure about this one yet, but we'll do the concept of movement, capturing like the movement in game. So I think that's a good list. So let's start, I guess we can start by defining the data structures for our components. So we'll take the first one on the list, position. And so position will be pretty simple. We will, so we can just use 8-bit. This we'll do X, Y, and every component will also our object ID. So that we know what this would be, kind of the components reference back to the object that is in turn pointing at it. So position, what else we got? Visibility. Our object D. And what do I have here? Oh, okay, so this would be like its visual representation on the screen. So we're gonna have things like, did I define, let's see, console. Okay, I did define the concept of an ASCII jar, so we will have an ASCII. So this will be the glyph that's represented on the screen. And then we also would like a foreground color and a background color. So those are pretty twos. Take care of it for visibility. And then physical. I think leave it at that for now. ID, and then so in this case we're going to have some flags that basically does this physical thing block movement? So can things move into its space? And then we would also have blocks sight. So can when we do our when we determine what area of the map is visible or what things are visible, does this thing obstruct your line of sight? Can't code without coffee. Alright. Let's see. Does that might be enough to start. So let's bring this. I don't think yesterday I did not link our game code in. So let's bring it in. And so let's see, how do we want to, other things we're going to need is obviously a way to create in-game objects. So let's see, my notebook, it's pretty much my notes for today, so let's this out. We are going to want something that's create game object. Now we can decide on our naming conventions. So let's look at our PT console. So naming conventions, I basically use, this is a library, I prefix everything with the library prefix, and then so let's So creating our game object. Let's see. How are we going to hold our game objects in world state? This is our entity. Oh, sorry, that is not our entity. This is our entity. And then these are going to be our component definitions. I don't think I can do... Can I? Let's give this a whirl. I don't remember. I'm still... My C brain is rusty, so let me see if I can... this will compile or not. I'd like to... So ultimately I'd like to do this, have this component array be no bigger than it needs to be. But I'm not sure if this needs to be a defined constant at compile time. Let's see. Whoa, what do we got going on here? Player UndexO 70. Player. Did bringing in this include somehow screw things? Yes, it did, because I've got a syntax error at the bottom of the file. That's crap. Alright, let's try this again. Okay, that's much better. So it compiled. Alright, so that's helpful. You can get rid of this max component count though. So let's get back to our create game object. Let's see, what are we going to want to... It will return a game object. Probably a pointer to a game object. Let's just leave this in a compilable state. That'll compile at least. Okay, how are we gonna build our world state? So let's do... We're gonna have some data structure that holds all of our world objects. So perhaps just to get started, let's just do it as an array for now. So we'll do game object. objects, and for now, let's define just a max game objects, and let's just set it to 1,000. I think that's gonna have to be bumped pretty quickly, because if we're representing each individual wall as a game object, you know, a map will have several hundred, at least, objects that just represent walls. But this is a good start. So we'll do game objects, maximum size, or initial. We'll have it set at a fixed size right now of 1,000. I can see us in the very near future changing this to a more dynamic data structure where we're allocating space as needed, but for now this will work. Let's do... So we'll have our create game object, and then we will also have, I'm guessing, destroy game object. And we'll give it game object. And this game objects should be, for now, will be it'll be a global. Which again, global variable is just a type def to static, you can see here. Alright, so creating a game object. Oh, hey, that one Dutchy guy, how's it going this morning? Or perhaps this afternoon, wherever you might be in the world. Welcome. Alright, so let's just do a create a vanilla object, and then another thing that we're going to need is we're going to need the ability to add a component to the object. And so we'll take a game object, and we will take, I guess, trying to learn libgdx while browsing streams. Yeah, that's a good library. It's a nice cross-platform. Are you doing? What language are you using for that? Is that Java, I believe? Game object. So we're going to need to basically tell this function. Yeah, Java. Good, good. I've done a fair bit of Java programming. In my day job right now, I'm building an Android app. So I have some familiarity with Java. I'm not using libgdx for it. It's more of a business app, so haven't done much libgdx, but how's it going with that? Modding for different games. Nice. Did you do any Minecraft modding? So we're going to pass in our game component here. the game component type that we want to add, and then we are also going to pass in the actual component itself. So start with Minecraft. Yeah, the Minecraft modding scene has changed quite a bit in the last few years. I did some very basic Minecraft modding a couple of years ago, and then I think it was with Bucket or something like that, and then they changed the platform and disabled that type of modding, and I never went back to trying to learn the new modding, but I enjoy other people's Minecraft mods. Some of them are quite amazing, and Minecraft itself is so unbelievably extensible that, well, I mean, that's probably one of the reasons that it's been so popular for so long, is that you get tired with the vanilla game, then there's a whole nother world of mods you can play. You turn Minecraft into something completely different. Turn it into the game that you want. Okay, so game component, and then we're going to pass it the actual component. So we'll call it component data. All right, so this object. How are we gonna? Okay, so one thing we need to do is figure out how to represent whether. So if this is consider this game objects array as a big chunk of memory that may or may not be used. So we need a way to indicate, when we're looking through this game objects list, whether a particular slot is being used or not. So I guess we could do that just by looking at the ID, and if the ID is 0, then the game object would not be used. Oh, there's a console. Oh, man, you know this window management. I apologize. That is not the point. Still, let's hide that terminal. There we go. Sorry about that. Alright, so just to recap what I've blocked with my terminal window, I added some world state here, and then I'm starting to flesh out some game object management functions. So right now we've got create game object, we've got destroy game object down here, and then add component to game object. And I suspect that there will be other object management functions that we'll need, but we can build those out as we go. So this is the world state. It's going to hold all of our game objects. We're also going to need data structures to hold all of our components, but let's just focus on the object first. So if we decide that if a game object's ID is 0, that means it is not in use. That seems reasonable. So our create game object is going to look like, what we're going to want to do is find the next available object slot. This is So look in our game objects list. So if game objects at the index, if the ID is 0, then we're done. We found an open slot. So definitely what we're going to do is want to break out of our for loop. And let's get a return. Not using an engine or framework at all, and in creating that. Yes, that is correct. I'm part of the reason for this entire project is I want to dive into the algorithms that are necessary, as opposed to using a library that will handle some of that stuff. The only thing I am using a library for is I'm using SDL to handle the cross-platform graphics and input handling and sound, because I just those problems and those algorithms are not as interesting to me. They are very interesting, but I want to get more into the algorithms that are directly part of the game mechanics. So I'm using SDL so that I can get the cross-platformness with respect to video and sound and input for free or for very little. But everything else is going to be coded by hand. So all of our rendering functions, I mean, I'm using SDL to put pixels on the screen, literally just draw pixel memory to a texture and then put that texture on the screen. Alright, so we're going to start this return. This will be our return value. So we'll set that to null for now. Turn that from our function. So if we find an open slot, we're going to grab a pointer to it. So we'll grab the address. And we're going to break out of this for loop. So if we fall out of the for loop and we have a valid game object reference, we're going to initialize that game object now. So we want to set the ID so that subsequent calls to create game object, it'll now recognize that this object is in use. Something that, yeah, well, I'm trying to limit scope as much as possible, but it is a big project. And part of the reason I'm doing it is I've been away from C for a while. I've been operating at higher level languages. You know, most of my programming these days is in Swift or Java, and I kind of want to get back down to closer to the metal because it's fun, it's interesting, and you know, it's fascinating to me how all the different bits move around at the lowest level. Okay, we're not truly low. I'm not going for the assembly language programming. I've done that before, but I'm not doing that now. And but this, it's oddly satisfying when you get this stuff to work and you truly know exactly what the computer's doing. So if you're interested in following along, you know, hit the follow button, and we'll be at this for several weeks or months, depending on how crazy it gets. Alright, so we're going to set our Go ID. I should probably actually set that at this point when I have the index. I'm just going to set the ID at this point to the index in my world array. So I will set that up here. Go ID equals I. Thanks for the follow. Vince Crack, how's it going? Alright, is there any other initialization that we need to do right off the bat? We're not going to need to set... I think at this point we're going to want to assert that... Got another follow? Hey there, that one Dutchy guy, thanks for the follow. So I think at this point I want to have an assertion because I don't ever want to be returning, I don't ever want to be calling create game object and not returning a valid game object. So I am going to assert right now that game object is not null. So that at that point when we hit, right now max go is set at 1,000. I think we're going to exceed that fairly soon. When we do hit that point, we'll assert and, you know, the app it'll crash, but this is something that we never want to happen in the actual game. So when we hit it, I think that'll be the time when we'll revisit our memory allocation of game objects and we'll go with something more dynamic. But alright, so go is not null, and we'll be returning our game object. So the converse of that, creating a game object, would be destroying our game object. And so if we're handed a game object, obviously one of the things that we're going to want to do, and that's a pointer to that object, so we're going to set that ID to 0, which will mark it in our world state as unused. What we're also going to want to do, and we'll figure out exactly what we're going to do this, how we're going to do this, is we're going to want to clean up any components. And once we figure out how the components are truly going to work, we can come back and fill that in. Alright, is that... Let's pick a couple components and just start building them out. So position is a very important component, obviously, of all of our stuff. Most of our objects are probably going to have a position component. So let's do that. How are we going to represent our position components? I guess at this point we can do it in a similar fashion. lost my chat connectivity. Still trying to figure out all this streaming stuff. In addition to shaking the rust out of my C brain, I'm new to this streaming stuff, so that is its own adventure. Alright, how fancy do we want to get to these? So we could do something like that and just have a different array for each component. That doesn't seem... seems cumbersome. Every time I add a new component, I'm going to have to add a new... maybe a two-dimensional array is the answer at this point. No, I'm going to need to define the size of those structs, so maybe for now that'll work. I'm going to do some thinking on that and see there's... I can see us refactoring that in the near future. So let's write the code first to interact with our object. This is our main loop. This is before we enter, sorry, this is not our main loop. This is our main function right before we enter the main game loop. So we can experiment with some things here. We'll have a game object. We'll call it player, and we want that to be a new game object. And so then what we're going to want to do is, instead of, this is our player struct right now, let's get rid of that in favor of our new game objects. So we're going to have a player, and let's add a component to that, a position component. So we'll do player and we'll take our player object and then the component. So in this case, that would be position, right? Now let me, hold on. This is the C rust coming into play. I need to see. I got my handy dandy pocket reference book here. By the way, O'Reilly books typically high quality, and these little pocket references, they have them for pretty much every language you can think of. They're really handy. Okay, yeah, I think that's going to work syntax-wise. So we're going to specify that we want the position game component, and then so our game, it actually takes that component data. So let's take let's create a variable here. And we can our position has an object ID, and then it takes X and Y. So our object ID in this case is going to be player object ID, right? Nope, it's just player ID. And then X and Y coordinates. So let's make it the 25, 25 that we had down below. So that'll initialize our position struct with player ID and then 25, 25. And then we're going to pass it to add component to game object, which we'll implement in a second, but what we wanted to do is take this player object and then add this position component to it. So then we'll want to update our render screen as well. Yay, naming conventions. Okay, so right now, player was a global variable. Let's get rid of that. Maybe we actually want it to still be a global variable at this point. Let's do it's no longer going to be a player though, it's going to be a game object. And it's going to be a game object pointer. And eventually it will not be a global variable just like this. Eventually render screen will basically loop through the entire world state of visible components, visible objects, and render them all to the screen, which should be, it doesn't know what it's rendering, whether it's a player or a monster or a wall. It's just rendering a game object that has a visibility component. But we'll get to that in. I guess we can do that now. When we implement our visibility component, we'll do that. So we'll do that in a bit. Player is now a pointer to a game object. So what we're going to want to do is we're going to want to get a component for an object, because right now player is a game object that has some list of components. So what we're going to want to do is we're going to want to do something like get a position. I guess it would be a position pointer. Call it just player pause for now. And we're going to want some kind of function that is like get component for object. Let's be consistent, game object. So we'll pass in our game object pointer. And again, we're going to want to know what kind of component. This is the call, not the definition. So we're going to want to pass in our player, and we're going to want to pass in comp position. And since this will be somewhat generic, we're probably going to have to cast that to a let's resize this a bit. Oops. So we're gonna basically ask to get this position component from our player game object. And then at that point we'll have player pause, and so instead of the old player position X, we'll have player pause X, right? Because position has an X and a Y. And then player pause Y. And that, in theory, will grab the X and Y from the position component of our player game object. So it often helps to write the code using functions in the way that you want them before you write the actual functions. It kind of helps to, rather than guess it when you're writing a function, rather than guess at how it's going to be used, figure out exactly how it's going to be used in your optimal situation, and then write the function to fit that. So let's go back over and write that function now. I think there's a couple functions we need to write. So add component to game object, which we're using down here. It's going to take our object that we're adding to, and then the component, the enum of the component that we want, and then the actual struct for that component. So the first thing we want to do is just make sure that we have a valid game object, because if we have a game object that doesn't have an ID, then we're kind of dead in the water already. And then what we want to do is, so we're going to have our world state where we have a global memory block for all of our position components. So similarly to how we did the game object allocation, we'll allocate our component. First we need to figure out what component we're dealing with. So we're going to want to switch on our comp value. And we'll write a default case, in which case we will assert I think we can send an insertion string? Not 100% sure. But basically, if we get past a component that we don't know about, then we should immediately fail and fix that, because that's not a normal game condition. That's a programming error. I believe I also need to bring in the assertion header. Again, I'm using my handy dandy. It's just an expression. It's just a test expression. It doesn't take a string to output, it looks like. But it will write the expression, function name, file name, and line number to the standard error stream, which in this case is terminal, and then abort. So. And we need to bring in cert.h as well. So bring that in. let's make sure that we haven't gone too far down the road and broken things horribly. Just gonna do a quick build. Okay. The time being. One thing that I have screwed up with is in Java land, I'm in C land, so we want nulls to be all caps. And this is just an immediate fail. Alright, so in the case of us getting handed the desire to add a position component, we're going to want to essentially do the same thing. I should probably write a helper function for this, but for the time being, we can't forget our break statement. We don't want to fall through our case. So in this case, we're not operating on game objects. So how are we going to recognize that well, one easy way, at least for the time being, to know whether a position slot is filled or not would be just to assume that the corresponding the index, so if our game object is in slot number 3 of this array, I think it's safe at this point to assume that position comp, the slot 3 would be the position object that corresponds to our game object. So maybe we don't even need to... Oh, we still need to indicate whether a component is in use. So we will do that by looking at the object ID. So in this case, it's if our object ID is 0, let's grab let's just test it. Okay, you know what? Let's assume that the index into the position comp matches the index into the game objects array. So in this case, our position, let's grab a pointer to it, is our, grab it from the position comps array, and we'll grab it from our object ID, game object ID, be our index into the position array. And so we want to initialize our position. We want to say it's in use by giving it a non-zero object ID. So again, this will be and then position the x and y coordinates. I guess we can just default those to be put 0, 0. I'm sure that that's super essential because I think the first thing we'll be doing when we add our component is, oh, you know what? I'm not even paying attention over here. I'm not paying attention to the usage. I'm handing it the position. So this is valid. However, this position I want a reference to cast this to a position on my comp data, because I'm handed the data. I forgot that I was handed the data. So this, instead of setting it to some random arbitrary value, we're going to actually set it to the data we're passed in. So that gets pos data x. Pos data y. And we're actually already given the player ID as well, so we can replace all this with something much simpler. And what we want to do in that case is take our position comps and the object ID index, and we want to set that equal set it equal, then we've got problems about variable lifetime. Because if we just set it to comp data and then comp data goes out of scope, then this points at garbage. So we want to make a copy. Alright, let's make a copy then. Alright, so we're going to need to just do a mem copy, but first allocate the memory. Let's just go with copying the data straight over for now. There's definitely going to be an optimization pass where we restructure how we're handling our world state memory. Let's just get the basic entity component system working, and then we can figure out how to get it working more efficiently. Step 1, get it working. step 2, get it working more efficiently if needed. Sometimes step 2 is not needed. Alright, so we're copying our given data into our world state. We're setting the game object ID. Alright, so over here, we've added that component in now. So, destroying our game object, we have this little to-do about cleaning up components. Now we know a little bit more about how we're using them. So in the case of position, or in any of our components are going to have an object ID that is set to a non-zero value. Well, you know what? It's actually not a non-zero value. It's going to be, because 0 is a valid value, if we want it to be. That is not quibble over those details right now. Let's say a non-zero value means that it's in use. So what we're going to want to do is clean up the other components used by this object. If we're given the game object, it has an ID. At least in this case, we're going to take our position comps, and we'll look at the one at that particular slot that corresponds to our game object that we're cleaning up, and we will set the object ID to 0, indicating that it is no longer in use. So destroying a game object will also mark the corresponding components as no longer in use. All right. What other functions? We need now we need to write our get component for game object, right? So it'll take the game object and then the component that we're interested in. And it will return in this case, we're casting it to the one we want. The function itself will return a generic pointer.
I always seem to make the same mistakes. Too quick to fall too fast.
And we're passing it in player, which in this case is a pointer. So. And then the game component. Yep, game component. Alright, so if we go up to our game object, we see that our components are in an array. Each object is pointing to the components, that is one thing that we missed in our add component to game object. So once we've added that, we also need to update our game object.
Repeating history, when will I learn? I miss the way that you smile.
Components, and in this case, the index is going to be our component ID. I believe we want this, right? The address of our component. So this is updating our position component, and then this is adding a reference to that component in the objects list of components. So in our destroy game objects, we also want to clear out our components. So do we want to just reassign? Treat this particular. We can just loop through it for now. What do we call it? Component count. Ah. Our components array, we're just gonna clear that out. I'm also going to want to do this. Oh no, if I destroy, when I destroy it, if I clear everything out. Perhaps I want to do this when I create the game object so that I'm starting with a clean slate. I know that I'm starting with a clean slate as opposed to assuming by starting with a clean slate. So when we create our game object, we will make sure that we go through and null out any component references. So if that particular slot had been used before and we were reusing it, we clear out any references to components that were being used by the object that previously occupied that slot. We'll move our assertion up here. we're into an error with comparing the game component enum value to. We'll see. Alright, so getting a component for the game object. Basically what we're going to do, this becomes rather straightforward. For the object that we're given, we're going to return a component that's at the index that we're interested in. And the reason that we turn this into a function now, instead of just putting this one-liner up here where we need it, is because I guarantee you that our world state implementation will change as we go. And so rather than having to update all our one-liners, wherever they may end up sprinkled throughout the code, once we get into the weeds a bit, we can update the function. And the all of the places that that function is being used, that code doesn't need to change. We can encapsulate the change to the function body itself. All right, I think we've implemented the functions that we need to now. We've got our get component for game object. We've got our create game object, and we've got add component to game object. So right now we don't have a need for destroy, but we'll exercise that a bit. Let's see how we're doing. Alright, I've got another 34, I've got another null, miscapitalized null here. Wait a minute. Why not? Oh, I didn't save. Huh. Oops. Okay, let's get a proper build now. Alright, add component to game object, actual parameter is not to pointer. Parameter 3. And that is at line 77. So they are 100% correct. That is not a pointer, that is a stack object. So because we want add component to game object to be generic, we need it to be a generic pointer. So we are going to need to make this into a pointer. And what we are going to do... Oh, you know what? I'll just do this.
There is so much we can learn in the universe. It is the frontier of
Again, C rust. Sorry about all of the C rust in my brain. Alright, and then we're just complaining about pos_y is not a member of game object. And that is correct. So we must have some artifacts from our previous implementation. Ah yes, our movement code. So, in this case, like we use in our render screen function right now, we're going to borrow that same functionality here. We are going to grab our player position and replace our old implementation with our new entity component implementation. That should give us what we want. So up here, position, XY, got a position pointer. All right, and we've got a build. Let's throw the switch and see what we've got. And we crashed. Okay. It's always exciting when you crash right off the bat. So we've got some sort of memory issue, which is something that is you definitely need to deal with that in C. It's part of the danger of working so close to the metal. Alright, so let's give it a quick visual check, and if we don't see something, we can throw it into the debugger and have that help us figure it out. Alright, so we've got our game object player. Are we allocating that? Let's just make sure. So in our player create game object, our game objects here are allocated here as part of the, they're on the stack since we're declaring the array size right here. Create game object. We're grabbing a reference to it here, so game object seems like it's, that should be okay. We should have that memory. We're adding to it, we're declaring a position, which again, we're declaring this on the stack, so we should have this, and then we're passing a reference to it to add component to game object. So it takes a pointer to a game object, a component, and a pointer to our component, which in this case is the pos structure. So we access position comps here, which again is declared on the stack, so we should be okay. This would be another good place for a breakpoint. Debugging. Casting that to a position pointer, and then we're setting values. So both of these should be valid memory. So then we're getting a component, which, are we setting this properly here? We're setting that component. It would be good to step through some of this stuff just to make sure that it's working. So maybe we'll verify that we're doing all that stuff properly. Let me fire up Visual Studio. I'm gonna run. This will be. Let let me try opening our C file. Let me allow you guys to see what I'm doing. Why is this so... Can you not see that? Okay, there you guys. Should be able to see that now. Okay, so I've opened up dark.c in here, and I'd like to set a breakpoint. I'll have it set it when we're creating our game object. That's really where the first hint of trouble will likely be. But I will set breakpoints in other interesting positions. So like basically anytime we're calling into this new entity component system we're building. So the get component here, the create game object, we'll step through add component as well. And then again, get component down here. So let's open up game file as well. Let's make sure that just put a breakpoint in each. Function here just to make sure we're getting called when we think we are and that we aren't getting called at some point where we're surprised about it. So now the thing is, I need to attach, but the process isn't run. Can I do that? I do that. Try debugging. Is this gonna... Perfect. Alright, so we have an unhandled exception. Are you guys... Sure, you guys can see this. Okay. Why are you seeing... It looks like you guys see the terminal? Doesn't make sense. Is that the game window? Oh, I'm sorry, that's the game window. Okay, so so it loaded up in Visual Studio and broke. Can I get a stack? Add component to game object looks like is where we started to run into the problems. So can I restart this? Doesn't look like it. Did it hit my assert? It looks like it did. So my object ID that I was passing in is 0. Look at that. Why is that the case? So my create game object must not be saving things properly. Let's go back and see what that looks like. I'm setting go ID right here equal to I. Oh, you know what? That's the problem with the I alluded to this before. I think we want our invalid object to be -1 so that 0 is actually a valid item, a valid object ID. Because otherwise I'm going to trip over that all the time because you loop starting at 0. So it grabbed the first item in the array, which actually is a valid open slot at slot 0, and then it assigned the ID to 0. So when I asserted, make sure that something's not 0, that's kind of a crap assertion right there. So let us, when we initialize, can we, in a struct, can we assign an initial value? Don't remember. Is that going to run val? Let's kill our game. Close down. Visual Studio. Yes, I want to stop debugging. Cancel that. I think in my struct I can't do that. I cannot. Yeah, it doesn't let you initialize inside of a struct, I believe. So, do we want to leave slot 0 as unavailable? Or do we want to change our assertion? Let's change our assertion. First of all, make sure that object ID is not -1. We're gonna need like an init game state routine, which is okay. We'll need that eventually. You know what? For now, to get this working, let's just change our assert for the moment, and we'll use that slot 0. And when we destroy an object, set it to -1. It's not in use. case, we're going to just... It's still going to be problematic. Do this the right way off the bat. So I'm going to declare the 0 slot off limits. Should do it. So we're going to ignore the 0 slot for now, because we want the ID of 0 to indicate unused. Okay, we're built, and let's give this a run. Alright, so we've got our little @ sign at, looks like position 2525, so that means that we successfully replaced our starting position. And now the moment of truth, can we move? Oh, yes we can. Excellent. Can we move to the edges and not crash? Yes, we can. Okay, alright, well that's encouraging. So what we did, let's close this terminal. What we did is we replaced yesterday we were statically defining where our player was positioned, and we were hard coding it right into a player struct. And today we generalized that into what will be the system that represents our world state, which is an entity component system. And we implemented the first of our many components that we'll be building out, the position component, and successfully tested that everything was still working, which is great. So next steps, we're going to basically be building out our entity component system into more full-featured system. We can go ahead and start work on visibility. Hey Bison1Q, C#, you're a C# fan, yeah? That's cool. You do Unity stuff, or what are you doing in C#? I have done a fair bit of C# programming in my day. I actually started working on .NET, developing .NET-based applications when .NET was first introduced. I'm a bit of a code dinosaur in that respect. And I agree, C# is a nice language. All right, so let's go ahead and start banging out our next component, which will be visibility, I think. So if we can just render a couple different, we'll just put together a couple different objects, core and MVC, yep. ASP.NET, yep. I worked for many years building ASP.NET websites in C#. Using in the framework before MVC frameworks came out. MVC frameworks were a great improvement over the way that we used to build it. So why am I doing C? It's just, you know, I've done lots of different higher level programming languages, and you know, just fun to get closer to the metal. Sometimes it's frustrating, as all you know, get out sometimes, because you do have to think about memory usage and, you know, pointers that may be pointing at garbage, but it's useful. Even if you're working in high-level languages, it's very useful to know what's going on under the hood. Alright, so we've got our next component in the system, which is going to be our visibility component. And again, it's got an object ID, it's got the glyph, which is the ASCII character that we're going to want to draw on the screen to represent that particular game object, and then it will take a foreground color and a background color. So let's again write some usage code before we dive into the actual implementation of the component itself. So let's say we want to add a wall, which we're going to be doing very soon, because the next thing on that to-do list is to start generating the dungeon maps. So let's figure out, let's do a game object that is a wall. We'll create our new game object, and then we can give it a position. The wall will have a position. And we can give it, in this case, it'll be our wall. Okay, at 18 years old, program for fun. Yeah, that's a great way to start out. I started coding, I was probably 13 or 14 when I started coding, and just writing, I had an Apple II computer, so I was writing in BASIC, and then gradually moved on to Pascal, and ventured into the world of C and C++. And this was Turbo Pascal, Turbo C, back when Borland was a company. And then basically I've been programming ever since. And that's what I do for a living now, and I love it, so it's good for you. Keep it up. I've turned several hobby projects into full-time jobs, so I basically learned programming for the iPhone as something that I wanted to do for fun, and one day my boss came in and saw that I had some iOS programming books on my desk, and he's like, "Hey, you know how to do that?" And I said, "Yeah." And so I moved positions in that company and became, lead mobile developer. And I've been doing mobile development for the past 6 years. So never stop learning new things, because you never know what opportunities you'll be presented with. And if you're interested in all of this stuff, please give me a follow. Be notified the next time I go live. I'm going to try and stream, if not daily, at least several times a week. Alright, so our wall position, we're going to pass it our ID, and then we can give our wall position, let's just do, to make it 30, 25, so it'll be to the right of our player starting character. And let's add that. In this case, it's going to be component position, yes, and reference to our wall position. And then we're going to want to add our new visibility component. So this structure takes, again, the object ID and then a glyph, a foreground color, and a background color. So do that same wall ID. And then for the glyph, so it's ASCII character, which, let's see, is that looking for an int or is that looking for an actual, it's a character. Okay, so we can give it a character. So let's make the hash mark be our wall glyph. And then foreground color and background color. So in this case, it's 32-bit integer. Let's just do white on black for now. So foreground and background is going to be black. And let's add our component to our wall. This time our component is going to be visibility. And we're going to send wallviz, a reference to a wallviz, into the function. Visibility, yes, okay. So what we also want to do, the other visible object in our game is obviously our player. So we're going to want to enhance the work we're doing with our player up here. And we are going to just call this add that into our player object. Now, these blocks of code, I mean, this looks like a lot of code to add an entity and to spin up an in-game object, and it is a decent amount of code, but we're not going to be doing this every single time we need to add an object to the game. We're going to write in fairly short order, we're going to write a helper function that is going to kind of hide this, make it easier. But for now, we just want to make sure that our entity component system's working, so we can live with the wordiness of the code. Alright, so we've added a wall. Let's make our player more visible. So instead of white, let's see, RGB, let's make him green. So that'll be, we'll set the green bits to, full on maximum green, and then we'll set these are the red bits, and then these are the blue bits. Because again, the color format here, it's 32 bits RGBA, red, green, blue, alpha, and 8 bits for each of those color components. So we're adding the wall. So now we need to change our rendering function. I think that let's change our rendering function. Right now we are only rendering the player, and we're doing it by declaring the player as a global variable that we have a global reference to, which may prove to be useful since for that one particular player object we may want to do that. But for now, I don't want to have a global player reference. What I want to do in the render screen is I want to have this render screen function render every visible object in the world state. So, hey MathK, thanks for the follow. Thanks for joining us in our quest to build a classic roguelike. Should be fun. So render screen, this would be an example of a system in the entity component system design methodology. Render screen will operate on entities in our world that have a visibility component, and it will render those to the screen. So what we're going to want to do is, instead of dealing with a pointer to our one specific player object and rendering that, what we're going to do is we're going to want to loop through every single visible object in our world state and render those. So basically, to write the usage code, what we want is we're going to need max. Okay, so we have max go. That should be visible at this. So for now, we're going to have a and again, let's do this. We're going to leave that 0 slot empty. That's going to trip me up. I'm going to have to fix that. But for now, let's leave that empty. Skip over the 0 slot. We're going to loop through all of our game objects. And we will say if game objects, this is our global. We don't even need to operate on game objects. Once we're going to build out our visible. So we'll have something called visibility comps. And we're going to test that has each visibility component has an object ID. So if that object ID is greater than 0, which means that it pertains to a valid object, then we're going to render that visible object to the screen. So we'll do our put character at. We're going to need our position. Maybe we do need to look at the game object and not the visibility object. No, I think it's still more efficient to loop through our visible objects first, because we don't want to loop through every single game object and say, hey, are you visible? Let's loop through our visible objects, and then we can follow the object ID back to our game object and grab the position from that. So if object ID is greater than 0, we know I have a valid game object. We'll grab. We don't even need to grab a reference to the object itself. We can grab the position. So our position is going to be position comps, and it'll be our, we know that for now, why don't we use our interface? We're going to want get component for game object. Let's use the interface that we defined, game objects. And then we'll say position P. This is going to be a pointer because we're going to get back need to cast this. This will be get component for game object, and we'll send in our game object, which I believe needs to be a reference, yes. And we want our position component. It's a bit bigger. See that? So we're grabbing our game objects. And if we wanted to be less wordy, we could actually just throw this game objects brackets I into here. But for now, it's fine. Well, this actually performs a copy, so alright, so this will give us our position, and then we're going to need... So before we were just using our player position, now we've got our... So this line right here essentially replaces this one in a more generic fashion. We can get rid of that. And then we'll copy this up into our loop. So if we have a position component, this just becomes P arrow X and P arrow Y, and instead of hard coding specific color values, we have console put charet is going to be its foreground color and background color in that order. So foreground color and background color are part of our visibility component. So we've got, let's just make this more readable. So, okay, so that's our usage code, I believe. We're going to get a loop through all of our visibility. Objects or visibility components in world state. If we have a valid visibility component, we're going to grab the position component after following that back to the game object, and then we're going to put all that information, put a character, and again, we don't want to put the @ sign because that's hard-coded. We want our visibility we want the glyph, right? So now this render screen function doesn't know and doesn't care what it's actually rendering. It just renders everything that it knows needs to be visible. So what we need to do now is actually implement the visibility component. We've defined the structure that describes the data for that particular component, but we need to allocate memory for it and have it be part of our system. So I believe we called it visibility comps, right? Over in our usage. And we'll define that now, just like we've done our position comps. Create game object does not need to change. However, add component to game object does, because we need to support visibility. So, like we've done with position, we need to grab a reference to our, in this case, visibility comps. And then we are passing it in over here. We're passing in the wall, in this case it's the wall visibility, but the various visibility information is there. Oh yes, okay, so we need to cast the data object that's being passed into a visibility. And we need to set the object ID to declare that this guy is in use now. The music there, did I loop or something? What's going on? Weird. That was a weird transition. Alright, and we're gonna copy the information that we're provided, so we'll get the glyph. Equals our biz data. And then our foreground color. And the background color. Okay, and finally we need to set our object to point to the game object to point to our visibility component. Which is really this, isn't it? What are you doing that? Similarly, this can be simplified. Okay. So we've now implemented adding a visibility component to our game object. We're going to want to clean that up as well in our destroy. And I think that's it. Let's give it a whirl. No errors. Player undeclared. Oh yes, I removed my player. Let's see. Let's go to 77 player. That's no good anymore. Now it's no longer a global variable. Now I need to make it local so that we can still use it. What else we got? Too many initializers. Did I initialize one of my structs wrong? 80. 1, 2, 3, 4. Let's go to our visibility. One, two, three, four. Initializers is it expecting? You don't like the highlighting settings? This is a bit more comfortable on the eyes for me. I kind of like the blues and the grays. It's that is like a religious battle, right up there with what type of text editor you use and all that stuff. Do you go for what kind of highlighting settings do you use? Are you a white background with different bright colors? Plus, I'm kind of going for the whole aesthetic here with the stream. It's kind of a darker grays and blues and slightly greens. For me, as long as the different syntax components are distinct, different, different enough that works for me. All right, so saying I've got too many components here that I'm trying to initialize. One, two, three, four. 1, 2, 4. What am I missing? Sure, I've saved everything. It also doesn't like 84 or 86. There must be something just throwing it here. Because it doesn't complain about 78. Line 74 pauses in the pointer and doesn't throw an error. Oh, this pause is not a pointer. It shouldn't be a pointer. Ah, this is the problem. I'm declaring that as a pointer. There's the issue. Thank you, Bakija. Thanks for pointing me in the right direction. So I'm declaring these on the stack and initializing them right away, so they shouldn't be pointers. However, I am passing them by reference to the various functions. I just use a dark gray, blackish background, extremely colorful. Yeah, you know, I've kind of gone through many different color schemes. No, Rocky Jaw, thanks for that. You pointed me in the right direction. Let's give it a go. Yep, now we're compiling. Okay, well, we have something on the screen. It's not what we expected, but it's something. So we've got our we have two different color glyphs. They are not in the right position, and the player glyph is not the right glyph. But hey, all right, let's figure that out. Well, there's one problem. I marked my player glyph as the hash mark, so that would be, in that case, the program doing exactly what I told it to do. Incorrectly. And then let's make sure that we're setting our position correctly. So player position should be 2525. And I'm sending that position into my player object. And then 3025 is my wall position. I am sending that into my wall object. All right, so let's look at our rendering code and make sure that we're not being incorrect up here. And we may actually throw a breakpoint in here and see what's exactly going on. Let's do that. Building, and let's run it. Should at least see our @ sign. Yes, so now we've got the right glyph, right color, wrong position. Because that's showing up at 0, 1 for the, no, sorry, 1, 0 for the player position, and the wall is showing up at 2, 0. So it's almost like it's showing up at its ID position, which could be, are we sending the right? Let me hide my terminal so everybody can see this stuff. All right, so my position. Visibility is greater than 0. We're going to grab our position component, and then we're going to put our character at the glyph. Let's make sure that we've got our parameters in the right order. So put char at is going to be our console, our glyph, and then XY coordinates. Glyph, XY coordinates. So we've got glyph, and then X and Y coordinates, which come out of position and then our colors, which seems like that's correct. So let's throw that into the debugger. Run it. Alright, so it's running. Let's fire up Visual Studio real quick. Fire that up. Get that ready and then I'll show you guys what's up. Okay, there we are. I'm going to put a breakpoint right here, yes. And then we'll attach, and it should hit the breakpoint since it's running right away. Alright, so we've hit our breakpoint. And what's our I? I is 1, which is going to give us our position. Let's do a step. Get our position. So right now, that position, that object ID looks like junk. So I think we're getting the wrong position object. So let's step into the get component function. Just loop it again. Maria Mikkel, thanks for the follow. I appreciate it. Thanks for joining us on our roguelike adventure. So get components. What does our object look like? So it looks like components in position 0 and 1 are valid, which should be our position and visibility components. So comp in this case should be, is this right? It's comp. This comp position 0. I think this You aren't actually rendering the game in a console, are you? No, I am not. I'm using SDL to basically give me a pixel buffer. And so I have written a set of functions that treats that pixel buffer like a console. So that's what's going on there. SDL is basically just acting as a pixel buffer. So I throw my console into pixel memory, a texture in the case of SDL, and having that SDL render that texture to the screen. Hello, bucket of ducks. How's it going? So I think the problem, maybe I'm not referencing the right. I think perhaps using this is the issue. How do I? Let's see what this is. because value composition 0, that's not, doesn't make any sense to me. I want that to be an integer. Perhaps let's halt that debugging for a second. I want to go in and figure out that my assumptions are correct or not. So if I am sending in a game component and using that to index into an array, is that actually doing the indexing properly? So what I'd like to see is for comp visibility, I'd like to see that a 1. Maybe I shouldn't need to explicitly set that. Do I need to cast it to an int? Is that the trick? Let me see. See if it'll let me do that, and then let's build this. Oh, my game is still running. So, my game. What's that? Build. Okay, it doesn't give me a compiler, so let's run it. Still seeing the strangeness. So let's attach and see what's going on. Go. So it's going to hit our get component for game object. And let's step. Test is getting 0. Which in this case, yeah, that is what we want. We want 0 because it's trying to grab the it's grabbing our position, which is 0. So our object can I jump in here and see what this is? Alright, so it looks like the dereferencing is happening. Expect. Do I ever get the game component from?
I'm feeling nervous. Do you feel the same? Do you feel the
Oops.
same?
Just keep
Your
going.
smile makes me curious about you.
Glyph is right, it's our position, but it's just not.
Smiling at strangers in the dark.
That object ID is wrong. Object ID should be 1. Should be match our I in this case. It should be 1. Let's get the code more closely. Our add component. Seems like that's where we're losing our. Position comps slot, and then all right, let's put a breakpoint and component to game object. I suspect that that's not working 100% good. It's my Visual Studio not showing up. Okay. Let's do our I need to hit the breakpoint. To get this so that it launches and hits the breakpoint. I can't do that before I attach. So what I want to look at is this component here. So can we do this? Let's do that is. Debugging for a second. Kill them. Executable. Let's. Temporarily. Temporarily. Just down here so that I can test. So I can hit them in a breakpoint. Fire executable again. And let's breakpoint here. Let's attach. Okay, so now I'm hitting that. So what I am sending. What's the problem at the moment? The problem is that the position component for my game objects seems to have garbage. So I'm trying to figure out. I think I'm not initializing it properly. Grandma next floor, thanks for the follow. Alright, so let's step into this and see what's going on. Position. Oh, locals. Okay, my object ID is 1. That's right. So I'm grabbing a reference or pointer to the corresponding position, which right now has the proper data. My object ID of 1 and my X and Y of 25. So it looks like it is getting initialized properly, because this pause data that I'm passing in is the 25 and the 25. An object ID of 1. So it looks like that is indeed getting set up properly. So when I assign it to the components, is that where it goes squirrely? Object, components, my comp here is 0, that's right. pause has a let's look at the memory. If oh, look at that, it's those two are pointing at the right. Two should be. Oh, you know, thing, that's a reference. These two should be equal. What am I missing? I think I need lunch. Brain is deprived of food. Object components is a pointer, so I'm giving it get component for game object takes a pointer to a game object and the component and returns a pointer. So I'm sending it I'm not sending it a pointer to a game object. Hold on. Yeah, that should work. Because game objects itself is it's not a collection of pointers, it's a collection of actual structs. So that's a pointer to a game object. Casting that, gotta get back to a position. Figure this out again. will figure this out. I is one, so we're looking for the ith game object, which is the player, represents the player. The problem here is the P. This is not getting this references getting into the weeds.
Wasting time on my own. All the places you said we go. All this pain builds within. Footsteps fade, what could have been?
Game object.
Finally, I feel more free. The end of you and me. Let it go, let it be. My heart belongs to me.
I'm gonna restart my build. Hold on a sec.
Never gonna let me go, and I will never let you go. And now I'm feeling stronger, feeling stronger. You're never gonna let me go, and I will never
So
let you go. And now I'm feeling stronger, feeling stronger.
touch. Alright, let's figure things out. So, game objects. Merge statement in one slot. And then its components. Simple one component. Component position. It's going to be 0. So the 0th position.
All the places you said we go. All this pain builds within. Footsteps fade, what could have been?
Can I look at that game objects?
Finally, I feel more free. The end of you and
That's
me. Let it go, let it be. My heart belongs to me. My heart belongs to me.
Oh, that's right, it's up. It's my turn. So it's definitely getting referenced into garbage. Yeah, I'm gonna take a lunch break and I'm gonna come back and tackle this. I don't want to waste too much of your time on stream with this, I will gonna eat and come back at it with a fresh set of eyes. In the meantime, I will commit what's working so far with our entity component system, because we did manage to get a lot of it working today. And I will probably come back later this afternoon and figure this thing out. So thanks for watching. If you are interested in viewing past streams, archives are on YouTube. Hit me up with any questions or comments on Twitter at PDCodes. And then the source code, I always commit the latest source code right after the stream to the GitHub, so if you want to play along, you can check out the source code repo. And be sure to hit that follow button if you want to get notifications here the next time I stream on Twitch. Thanks for watching today, and I will likely be back later, so I hope to see you then. Take care.